Welcome to Human Health Lab, where science meets movement, nutrition, and mindset. Your journey to better health starts here. When most people hear the word creatine, they think about bodybuilders and bigger muscles. But what if I told you that creatine is not really a muscle supplement? It's an energy molecule used by some of the most demanding tissues in the human body, including your brain, heart, muscles, and reproductive organs. In fact, modern research suggests that creatine may influence cognition, aging, sleep deprivation, metabolic health, and physical function. So the real question is, have we underestimated creatine for decades? Today, we'll explore what science actually knows and what it still doesn't know about creatine beyond muscle. Creatine is a naturally occurring compound synthesized from three amino acids: glycine, arginine, and methionine. Your body produces roughly 1 to 2 grams per day, mainly through the kidneys and liver. Another portion comes from dietary sources such as meat and fish. Its most important role lies in the phosphocreatine system. Whenever cells suddenly need energy, phosphocreatine rapidly regenerates ATP, the universal energy currency of life. This reaction is mediated by the creatine kinase system, one of the fastest energy buffering systems in biology. Without this system, high energy tissues would fatigue much faster. About 95% of body creatine is stored in a skeletal muscle, but the remaining 5% may be far more interesting. Creatine-related systems exist in the brain, heart, testes, retina, skin, and many other tissues. The common feature: all of them have high and fluctuating energy demands. This explains why creatine research has expanded far beyond sports nutrition. Let's separate the strong evidence from hype. The strongest evidence remains in a skeletal muscle and high-intensity exercise performance. Meta-analyses consistently show improvements in lean mass, strength, training volume, and repeated high-power efforts. Creatine supplementation can increase muscle creatine stores by roughly 20 to 40%. But beyond muscle, several newer areas have emerged. In older adults, creatine combined with resistance training improves the strength, lean mass, and functional performance. For example, studies report improvements in sit-to-stand performance, a clinically important marker of independence and fall risk. In type 2 diabetes, creatine combined with exercise may improve glycemic control and glucose transport mechanisms. However, creatine should be viewed as an adjunct to exercise, not a replacement for lifestyle or medication. One of the most exciting developments in recent years concerns brain energetics. The brain consumes about 20% of the body's resting energy. Like muscle, it relies on rapid ATP regeneration. A 2024 meta-analysis found modest improvements in memory, attention, and processing speed. However, overall cognition and executive function did not consistently improve. In other words, creatine may help specific cognitive domains, but it is not yet a universal brain booster. Perhaps the most fascinating finding comes from sleep deprivation research. In a research human study, a high dose of creatine partially reversed cognitive decline after 21 hours without sleep. Researchers observed improvements in brain energy metabolism and cognitive performance. This may have implications for shift workers, military personnel, healthcare professionals, and athletes. Modern creatine research increasingly recognizes that sex and aging matter. In postmenopausal women, creatine combined with resistance training improves lean mass and lower body strength. Interestingly, improvements in bone mineral density are generally absent. The benefits appear to arise primarily through muscle preservation and improvement function. Emerging research also suggests possible roles across menstruation, sleep, and menopause. However, pregnancy and postpartum evidence remains limited. In older adults, the goal is often not bigger muscles, but maintaining independence. From a longevity perspective, preserving muscle function may be more important than maximizing muscle size. Does creatine damage the kidneys? Current evidence suggests that in healthy individuals, creatine does not impair kidney function. Serum creatinine may rise slightly, but does not necessarily indicate kidney damage. Does creatine cause hair loss? The concern originated largely from a single study showing changes in DHT levels. To date, no direct evidence demonstrates that creatine causes hair loss. Do you need a loading phase? No. Loading simply saturates muscle stores faster. Daily supplementation eventually reaches similar levels. Should creatine be cycled? Current evidence does not support routine cycling. For most healthy adults, the evidence-based default remains simple: 3 to 5 grams per day of creatine monohydrate. Consistency appears more important than timing. Loading is optional. Taking creatine with meals may slightly improve uptake, but daily adherence matters most. Among all commercial forms, creatine monohydrate remains the most extensively studied and best supported form. Creatine is not magic, and it's certainly not a cure-all, but among nutritional supplements, it remains one of the few interventions supported by decades of research. The strongest evidence still belongs to muscle and performance, yet modern science increasingly suggests that creatine is better understood not as a muscle supplement, but as an energy molecule for the human body. And perhaps the next decade of research will tell us just how far those efforts truly extend. If you'd like future videos on creatine and the brain, women, aging or sleep, let me know in the comments. If you're passionate about science-based tips on health, fitness and nutrition, hit that subscribe button and join the Human Health Lab family. New videos every week. Stay strong, stay healthy.